In this video, we are going to discuss two methods, the most common methods for evaluating single projects. So let's start with the first method, which is called the NPV analysis. NPV stands for net present value, and it is computed as the difference between the present value of all cash inflows minus the present value of all cash outflows over a period of time. So take note that in this kind of analysis, we are computing for NPV, and our NPV may be positive, 0, or a negative value. So this type of analysis is used in capital budgeting and investment planning to analyze the profitability of our investments or projects. So in the case of a positive net present value, so this means that the PV of your inflows is greater than the PV or the present value of your outflows. Okay? If NPV is positive, then we can conclude that our proposal is considered acceptable. So the second case is if we compute a 0 NPV. So this means that the PV of inflow is just equal to the PV of our outflows. So if we have a 0 NPV, so we can also consider the proposal as acceptable. However, if we have a negative NPV, we reject that proposal since our present value of cash inflow is now less than the present value of our outflow. Okay, so in summary, if NPV is positive, that means that inflow is greater than outflow, so it is acceptable. If NPV is 0, that means that inflow is equal to outflow, that is still acceptable. However, if NPV is negative, that means that inflow is less than outflow, which is not acceptable. Okay, so for example, we have here a project with an initial investment of 50,000 and it returns 18,000 pesos per year for 4 years. If our I is 12%, we are going to analyze if this project is acceptable or not. Okay, so using NPV analysis, first thing is that we need to draw our cash flow diagram. Okay, so this is for 4 years, so start tayo from 0, year 1, year 2, 3, and up to year 4. Okay, so at year 0, we start with an investment of 50K. So that is a cash outflow, 50K. And for the next 4 years, we have an annual return of 18,000. So that is a positive inflow or cash inflow amounting to 18,000. Okay, so using NPV, what we are going to do is to transform all cash flows into present value. So this 50,000 right here is already a present value, so no need to transform. Okay, however, for this annual revenues of 18,000, they are not in present value, therefore we are going to transform. Okay, so for our net present value, we have this negative 50,000. Okay, negative since the direction is downward. Okay, plus this 18,000 annually. However, these are uniform annual payments, or our A. So we want to find P given this A. So again, we have our formula. P is equal to A times 1 plus I raised to n minus 1 all over I times 1 plus I raised to n. Okay, so I'm going to plug in the value of A, which is 18,000, times our I is 12%, so we have 1.12 raised to 4 n is 4 since 4 years, minus 1 all over 0.12 times 1.12 raised to 4. Okay? So we can calculate easily the NPV with these values. Next method we are going to talk about is the IRR, or the internal rate of return. So this is also called the investor's method or the discounted cash flow method. Okay, so it is sometimes called as the break-even interest rate. Okay, so what is this IRR? So this is the rate of interest wherein our NPV is equal to 0. Okay, so essentially for this method we are finding for the rate of interest. Okay, so I here is missing. So IRR is the value of I wherein the NPV or the present worth of the project is 0. Okay, so what will be our decision? So if we have solved for an IRR, then we can compare that to the given MARR, or the hurdle rate. Okay, so if IRR is greater than the hurdle rate, so the project is justified. Okay, so next one. Okay, so keep in mind that the IRR is not the actual dollar value of the project. So it is the annual return that makes our NPV equal to 0. So the higher the IRR, the more desirable an investment is to undertake. Okay, so how do we solve for the missing interest rate, or the IRR? Okay, so this method of solving the IRR normally involves trial and error. Okay, so to avoid using trial and error, then we can use a mathematical software or even a spreadsheet to solve the IRR numerically. Okay, so let's have here an example. So AMT Incorporation is considering the purchase of a digital camera for the maintenance of design specifications by feeding digital pictures directly into an engineering workstation where CAD files can be superimposed over the digital pictures. Differences between the two images can be noted, and corrections as appropriate can then be made by design engineers. So the investment required is 345K, and the estimated market value after 6 years, okay, so N is 6, the market value is 115,000. The annual revenues will be 120,000, okay, whereas the annual expenses will be 22,000. So you have been asked by management to determine the IRR and also the net present value so that you can make your recommendation. So take note that the MARR, or the hurdle rate, is given as 20% per year. Okay? So using these values, so pwede tayong gumamit ng Excel. Okay? So let me go to my Excel file. Yan. So given the study period of 6 years, okay, so I can write this one, 6 years, okay, and then, okay, so 6 years study period, okay, annual revenue, so we have positive cash flow amounting to 120,000 each year, so starting from year 1, year 2, 3 up to year 6, okay. So your investment, which is 345,000, is a negative cash flow. Okay, so we have here negative sign. For the market value, again, it is only applied at the end of the study period, which is year 6. So we have here a positive 115,000. So annual expenses, those are negative cash flows. So we have here negative 22,000 each year. So to calculate the net income per year, so just add the entries per row. Okay? So since for year 0, isa lang naman yung entry natin. So our net income is negative for year 0. Okay? For year 1, so add 120 minus 22,000. So that is 98. Okay, so same is true with year 2, year 3, year 4, year 5. For year 6, your net income will be the algebraic sum of these entries. So 120 plus 115 minus 22, so equals 213,000. Okay? So take note that the MARR is constant at 20% each year. So to get the present value, okay? So this 98,000, so considering this as the future value after 1 year, so we are going to transform this into present value. Okay? So ang formula na gagamitin natin dito to convert 98K into present value is P is equal to F times 1 plus I raised to negative N. Okay? Take note that the N here will be this. Okay, so N equals 1, N equals 2, N equals 3, N equals 4, and so on and so forth. Okay? So net present value for year 1. So ito yun. Okay? For year 2, transforming this 98K again into present value. So ito yun. Year 3, ganito rin. Ganon. And so on. Okay? So to get the net present value, okay, so this 6-year valuation here is your NPV. Okay? So just add these entries. Okay? Itong mga nakabilog dito. So your NPV is 19,413 and this is greater than 0. So the project is acceptable. Okay? So for the IRR, so paano nakuha itong 22.03%? Okay? So in our spreadsheet, we have here a formula for the IRR. So just type the formula equals, then IRR, then open and close parentheses. So what you are going to highlight first is or are the values of the PVs. Okay, so ito yun. So from year 0 up to year 6. Okay, so i-highlight natin tong range na to. And then comma, B10. So what is B10 here? So the MARR, which is 20%. So that's just the simple formula to get the IRR. Now, if we could compare the IRR with the MARR, so take note 22% ang IRR samantalang 20% lang ang MARR. So this means that IRR is greater than the hurdle rate. Therefore, the project is economically justified.